Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate Let's look at another example now of a polynomial function. First thing we're going to do is do a sketch. Now let's begin our analysis. Let's start with domain. Like before, we know the domain is always all real numbers. The range is going to look at the y values. Now, hopefully you notice with this graph, it's going across the entire y-axis here. It's covering that whole part. So this range is also all real numbers. Now let's look at the intercepts. So my x-intercepts are the following. So let's list those. And the y-intercept, remember, if it's the origin, it's both. Now let's look at extrema. So I can see here that appears to be some extrema on these points right there. So let's look at these first. Let's do relative maxes first. So relative maxima means what in a local area is there a maximum. So I can zoom in here and see this area real close is going to be a maximum in that area. I can see this point down here is actually going to be a relative minimum in that area. So let's put it on that list. Let's zoom out. Now this point right here is also going to be a relative maximum. And I can see this point down here is going to be a relative minimum. All right, so now let's look at our absolute extrema. Is there any absolute maximum possible value here? So is there an absolute highest value? Well, if I look up here, I can see my graph goes forever. So the answer is no, there isn't any. Now let's look for absolute minimums. Is there any absolute minimum possible value this could go? Any low value? Well, not really. I mean, I'm looking down here and the graph goes forever. So let's look at our intervals of increasing and decreasing now that we've analyzed our extrema. Now, if I look at this function, I can see it's going to increase and then decrease and then increase and then decrease and then increase. It does a lot. So I counted 1, 2, 3 intervals of increasing and 1, 2 intervals of decreasing. So let's look at increasing first. So it's going to start from negative infinity. And will continue until -1. Remember, we're going to do the union. Now, when is the next time it increases? And it doesn't do it there, that's decreasing. Here it is. This is the next interval of increasing. So it increases from this relative extrema to that relative extrema. So we're going to use the x-coordinates. So that's from negative 0.39 until positive 1.179. Union, because we have one more. The next time it increases is this piece right here. So when does that piece begin? 2.611, and it continues, because of this direction, it's going to continue to positive infinity. So there's our intervals of increasing. Now let's do decreasing. Well, the first time this decreases, this piece right here. So notice it's going to start at -1 and end at negative 0.39. Union, because we have another one. The next interval is this piece right here. And it starts at 1.179 and ends at 2.611. So there's our intervals of increase and decrease. Last but not least, let's do end behavior. As x approaches positive infinity, so that's this part of the x-axis, I can see my y values are approaching positive infinity. As x approaches negative infinity, over here on the left, I can see my y values are approaching negative infinity.